All right, let's get started. Today I want to talk to you about Redis and Postgres. This was probably one of the more creative titles I could think of at the time. But Postgres and Redis sitting in a tree. So I actually want to start today with a story. And this story starts with an app. And this app usually starts with a relational database. I tend to see this a lot when, with a lot of the developers I work with, all of their applications and their businesses start out like this. There's usually some runtime that exists that houses their application, and then they talk to a relational database. In this case, I'm a Postgres guy, so we're going to keep this, scoped to Postgres. Typically, then, what happens from there is that Redis gets added to the mix, and the use case I'm showing you here is that Redis usually ends up as some kind of is used as a mechanism for background workers, such that jobs end up on that queue, and then some set of workers on the back end start doing something. Now, what does this mean relative to this? So I've seen those patterns in the past, and this was actually a really old post from Antares that talked about adding Redis to your stack. But this is actually a really old post because it's from 2011, and because of the patterns that I've been seeing, I sat there and thought to myself, what has changed since 2011 that might make adding Redis to your stack a little bit better now than it was in the past? So today I actually want to talk to you about this, the Redis FDW. For those that don't know, the FDW part of this is actually the foreign data wrapper mechanism within Postgres. Postgres has this ability to talk to other servers and services that exist outside of its own kind of realm and instance. So how does this work? You've got the two databases here, Postgres on the left, Redis on the right. The foreign data wrapper is actually an extension that gets installed in Postgres, and from there, that extension can then talk to any other data service that exists either on instance or outside of it, whether that be over some kind of network boundary or not. It's really up to the foreign data wrapper to implement the APIs that are provided by Postgres so that you can actually talk to this other data store. So today I actually want to tell you a few things, and that is first, by using the Redis foreign data wrapper, you can cache results without actually having to leave Postgres. You can cross-reference a lot of that data, reduce complexity in your application code, and maybe even replace Postgres functionality with that of some of the functionality within Redis. We'll see, maybe. So let me tell you about myself. I work for Heroku. Heroku is actually part of the Salesforce App Cloud. And for those that don't know what Heroku is, we are a platform as a service. And that means that we take something like this where if you think about deploying an application, you have to make decisions about who is your infrastructure provider going to be? How are you going to store your information? Do you need to do orchestration or containerization? And what is all the monitoring relative to all of this that you're doing when you're deploying your applications? We narrow this down so that really all you have to focus on as a developer is deploying, managing, and scaling your applications without having to deal with any of the operational headaches of managing all of that infrastructure. So this is the classic action that we point to at Heroku, and that is the git push Heroku master, which for your application code, once it's pushed via git to our build systems, it's built and then pushed to our containerization technology, in which that then gets pushed up and it's serving requests to any of your customers in their applications. So I am Rimas. I run product management for Heroku for our data services. That includes Heroku Postgres. We have over 1 million active databases right now. That also includes Heroku Redis. This is a service that we launched about 8 months ago, and we're already at over 100,000 active instances. And 2 weeks ago at Kafka Summit, we actually just launched our private beta of Heroku Kafka. I'm not going to go into that too much, but if you're interested in learning more, please see me after, and we can get you set up. So let's go in and configure Redis foreign data wrapper so that we can actually start talking to Redis inside of our Postgres. So the first thing I'd mentioned before was that this is an extension that lives inside of Postgres. So the first thing you actually need to do is just enable that extension. There's lots of documentation out there on how to build this, and it's actually pretty straightforward. the next thing that we actually have to do from there is then define the server in which we're going to talk to. So for this case, we're going to create the server Redis server and define the foreign data wrapper to use, and then give it the options that are needed. That includes the host name and the port. Once that's done, now we've got this definition of within the system called Redis server. And then finally, we need to give some kind of authentication mechanism so that we can say, okay, when we go talk to Redis server, how do we make sure we get in to get all the information that we need? So that's finally this last command, create user mapping for public. And public just means for the current active user right there, and then all other users within the system. So give it the password, and that's all you need. So one little plug for Heroku. I know this is not like a real vendor thing, but all the stuff that you just saw before, we actually provide some CLI mechanisms. So when you're in the terminal, you can actually create everything that you just saw prior with some of our built-in CLI commands. So that way, we take care of if there are any credential roles or any of that kind of stuff that happens. We will make sure that those are all up to date so that your connections between the services are actually all copacetic, so you don't have to worry about going back and fixing those at any given time. Okay, so now that we've defined how to talk to our Redis, what do we do next? And this is where the real meat of this all comes into play. And this is actually talking to the Redis system that we have there and defining tables within Postgres. So anytime you're going to talk to any of these foreign systems, you actually need to create foreign tables. And in this example, what I'm doing is actually creating a key value pair in a table, and I'm calling this table Redis scalar. And then I'm giving it the option of server, which is Redis server, which we had defined earlier, and then the options for that, which in this case is just database 0. By default, you always need to define database when using this foreign data wrapper, so it's always just a good idea to you keep that in mind when you're developing against this. Okay, so I've done that, cool, and now I can go back to my Redis instance, and let's say I set up this key value pair. I set presentation, and I'm going to say that this presentation has a value of awesome. Whether or not it is awesome will be for you guys to judge after this presentation. So then we can go back to our Postgres instance and then select star from Redis scalar, which was what I defined earlier, and now you can actually see this key value pair inside of my database. So from there, if you imagine, you can then cross-reference any of this data that is in Redis in your Postgres instance. Pretty awesome, right? Like, I mean, I'm excited, right? But there are a few more options when actually defining these foreign tables. These are the 4 that we present here, and actually I'm going to go through a few of these, and as the presentation goes through, I'll talk about the rest. So the first one is this table type, and table types can actually define the data structures that you're working with in Redis. So I'm actually going to talk about table type hash first. So when creating the foreign table, this is something that we've seen already, right? Create foreign table, Redis hash, and this is the name that I've given it. I've defined a key value pair, and in this case, where I've defined value, you'll see the data type of text with the brackets around it, and that is saying that that value is actually an array of text values. Again, server, Redis server, and then the options. I've specified database 0 again, and then table type is hash. Hit enter, everything's copacetic, and then I go back to my Redis instance and say, okay, let's start playing around with this and see what happens. I set this up, add my hash with a few keys in it, go back to Postgres and say, cool, now I can actually select from Redis hash, and now I've got this key value pair where the key is awesome, and the value is actually this array that I had defined earlier of today and 10. Now, working with arrays in here seems a little bit weird, especially since in Redis we actually define this as a hash. So, with a little Postgres magic, and I'm going to use a function here called JSON object, I can actually then turn that array back into a JSON type so that now I actually have some kind of form of hash to work with. And then from there, I can do anything else I want to, like pick certain keys within that JSON object if need be, inside of Postgres. So I want to be clear that when defining column types when you're working with the foreign data wrapper, you really need to make sure you understand which ones you're working with at any given time. So if I define the text with the brackets around it, you're actually going to get an array of text values versus if you use text for like hash table types, you're going to get text which is set up like an array. So you have to be cognizant of that when you start working with this. So let's go into the table type of list. Again, let's set up this foreign table, Redis list, key and value pairs. And this time, the table type is just list. Pretty simple in the options. Now, go back to my Redis, define a few different type of lists. I've got two of them actually, my list and your list. The first one has hello world, and the second one just has awesome. Apparently, I was on an awesome streak when I was writing this presentation. We go back to Postgres, select from the Redis list, but this time you see we have the keys and the values, and again, you'll see that these are defined as array of text. But what if you really just want to work with like one type of list? Well, I'll get into that in a little bit later. But what I do want to point out is that the Redis foreign data wrapper also supports sets and sorted sets as part of the table definitions, and you'll see some of that throughout the rest of the presentation. One of the other options as part of defining tables is actually the table key set, and this is actually only for set types. So when you are creating the foreign table, you'll notice that this time, instead of actually specifying a key, I'm actually only defining value. So the options, again, database 0, table type set, and the table key set is now my set. So when I go into Redis, add a few, issue a few commands here, and then go back to Postgres, now you'll see that when I select from Redis set, I'm only getting the values there and not getting the key type, because I've actually said to the foreign table, I only want to get the set that is defined as the key, my set. So this is actually kind of nice if you already know the keys that you're going to be working with. Now you've got these individual tables that you can just pull from. So going back to this and some of the use cases that were mentioned in here, I want to cover that today. So the first one was actually counting things. How can we actually count things better and actually use that information in more quote-unquote real time and actually tie these two systems together, Postgres and Redis? So this should be somewhat familiar from that article, which is you've got this counter where the prefix of it is some user, and it's delineated by user colon and some ID, and then it's got some expiration on it. Cool. Like this comes straight from that blog post. We again go through, create a foreign table. Redis counts this time, a user ID of text, and I decided to say count of big int. Options this time were database 0 and table key prefix of user colon. So what happens now is that anytime the Redis foreign data wrapper wants to go look and does a scan of all the keys that are in there, it will actually only pull up the ones that have user colon as its key prefix, which actually is kind of nice because if you're using Redis amongst a lot of different processes, you can actually namespace this stuff so that you're not colliding with anything else that's going on in there. So in this case now, I've done a select from Redis counts, and you'll see now I've got user ID of user colon 2, user colon 3, and their associated counts from Redis. And the cool thing here is that now I can bump that up against any of my other user information that's actually living in Postgres. But you'll notice that I've been given the whole key and actually not just the user ID. It's a little annoying, but that's a tractable problem in this case. And one of the things that I actually like to do, and I leverage Postgres in this case, is that I will actually create a view where I'll split those out, and then any work that I do amongst my application or any of the developers that are working in the Postgres database can then just query off that view, and now they've got a great way to just do joins and everything else against the information that are in here because the user ID has already been split out. That's just one pattern that I follow, and I'm sure there are others that are out there. So one of the other cool things that you can do now that you've got all these user counts coming from Redis, and I'm sure that you saw that we have that expiration on there, you could also start doing a little bit of data warehousing based upon that. So what I've got here is actually an insert statement into snapshots. So I've actually defined a few extra columns here, the one of which is actually the created at. And I use the view that I had created earlier to then say, on some kind of periodic basis, whether it be 60 seconds, minutes, hours, days, I can pull those counts out of Redis and start snapshotting that and keeping that over time so that I can do any associated analytics with this stuff. So in this case, I'm using a Postgres function called dateTrunk, which I've given it the system time, which is now, and just telling it, give me the current hour, and I'm just going to say that whenever my cron job runs to pull this out, it's just going to pull it out of Redis and then put it into that table immediately so that you actually don't have to create any extraneous application code to do this out, because one of the things that I had done prior to this was that I had code that was written that would do my own scans, find all of these user preface keys, and do exactly what I'm doing here. But you can think now that you could just do this in a cron job and actually just issue a pSQL statement right at the command line and it's done. So again, the benefits here are that you can start cross-referencing some of that information with between Postgres and Redis. Again, Redis for that very high velocity type information. And the second thing is now you can issue one query to take snapshots of counts in Redis, making data warehousing just a little bit easier. That's just one example, and I'm sure there's many others where if you're counting web requests or any other kinds of counts, you can now pull that into Postgres fairly easily. One of the other use cases that was mentioned as part of that blog post that I was talking about earlier is slow queries. So slow queries usually take the form of this, and there's usually some crazy extraneous where clause. It's got all sorts of stuff. I couldn't think of one to put up here right now, but there's a little bit of pseudocode that kind of shows this here. And again, one of the things that is challenging with slow queries is that when you cache these things, you have to worry about who's actually pulling the query at any given time, because for me, when I've done this stuff, I've actually done this all in the workers, and the workers are all trying to do the same query at the same time. So what ends up happening is that I have to create some kind of mutex across all of the processes so that they don't fall over each other. And that's usually what I have in this pseudocode here, where I've got top comments refresh time, and then I say, okay, well, based on the refresh time, if the refresh time is longer than it should be, go into this mutex and then say, okay, issue the query again, update Redis in the top comments, and then set the refresh time the last time it had happened. What happens here is that now you've got all of these other processes waiting and just kind of idling until that mutex finishes up, or that query does, and then they can go back and do whatever else it is that they need to do. So you've got these situations where your workers now are just kind of sitting there. So what can we do with the foreign data wrapper to make this a little bit easier? So I'm actually displaying here the users table, and this is really just a contrived example of kind of a leaderboard type situation that, let's just assume it takes a long time to query this thing. I select from users, and here's some example information that kind of comes out. I've got myself, I've got 10 comments, Chuck has about 10,000, and Lucy's got 300. Again, let's go back, create another foreign table, and in this time I'm going to call top commenters, and I'm going to make this thing an actual list. So again, servers, Redis server, options, database 0, table type of list. So what I can do now is actually insert into the top commenters the cache key and my commenters. And what I've done here is that I've already know where I'm going to cache this thing, and I'm just calling it my list in this case, and I'm using an array aggregation function because I had mentioned before that if you use text with the brackets around it to define your data type in Postgres, you need to make sure that the value that you're entering in there is actually an array itself. So this contrived example, I've just said, okay, my list, that's the key that I want, and I'm going to update it with, or actually insert it with this array aggregation here. So I do that, and then I can go back to Redis and look and see what's in there. And now I see that I've got this list with all this information in there like that. So that now all of my processes in that mutex that we had before, we can actually get rid of it. And now all of those processes just hit that key in Redis, and they can get everything else out that they need to. They don't have to worry about waiting anymore. But there is a little bit of a challenge here, and that is updating information. Now, I've got this update query here, and you think that you could probably do something like this, and that's actually not the case. The Redis foreign data wrapper doesn't need to, or doesn't allow you to do that. And from there, we'll get into it. So what if we need to show scores or counts? This was another example that was in that blog post. And this is the sorted set example, and this is some extra information that comes along with that. So again, we're going to create another table. This time, we're actually going to use the singleton key as an option and the table type of Z set. So the singleton key just means only look at this key when you go and pull information. The thing that you will notice as part of this is that now you've got value and score, and I've defined score as a numeric value. And that's up at the top. So again, going back to my updating comment that I made before. So one of the things that I wanted to mention was that we did an insert earlier, and if we try and do a second insert with that array aggregation, what you're actually going to end up with is this error that pops out that's saying the key that already exists for my list. So one of the ideas that I'd had in the past was like, well, maybe not in the past, but Postgres actually just came out with upsert, which means it's a function that allows you to, if the key does not exist, or if the information does not exist based on a unique constraint, insert it. If it already exists, do an update instead. So I thought, okay, cool, maybe I can pull this off with the foreign data wrapper in Postgres. So I tried this. I said insert into Redis set, gave it all the same information. My query that I'd put in before, put that in there as that subquery, and then said on conflict, the cache key, do that update, and do it where the cache key equals my list. Unfortunately, that didn't really work, and it was telling me that there were no unique or exclusion constraints allowing me to do this. So that really kind of sucked, and I'm kind of sitting here saying, okay, what do I do next? The challenges here are that you will get errors if the keys already do exist. Sets, lists, and sorted sets can be more of a challenge to update in place if you have many processes trying to grab the same key. And the thing is that right now in Postgres 9.4 and 9.5, you cannot put unique constraints on those foreign tables, so that kind of sucks. So really to kind of get around this stuff, you have to think about and get a little bit creative about how you create those keys as part of the queries that you're going to cache. And one of the processes that I actually like to do is put some kind of timestamp within my key so that based on today's date, the queries will get that information based on today's date. And if that one does not exist, it will go to yesterday's date, and then it just kind of ages out on this like rolling cycle. Atomic updates to lists, sets, and Z sorted sets will require some creativity. I mentioned that. And I pointed out the singleton key here earlier. And I want to say that you definitely should use the singleton key if you're going to be doing anything with sets, because now you have the value and the, especially the sorted sets, because now you have the value and the score that you can actually put together and then query on all that information. And as I said before, the nasty mutex code that I had written in my pseudo-code, we can actually get rid of that, and now all of these other processes can just pull the cached information out of Redis at any given time. So some of the caveats about Redis foreign data wrapper and Postgres is that I highly recommend that you use Postgres 9.3 and above and Redis 2.8 and above. Some of the functions in Postgres 9.1 as part of this foreign data wrapper actually do not exist, especially when it comes to things like singleton keys, et cetera. And the same applies to Redis 2.8. There are some things that are really needed to make the foreign data wrapper work well, and that is the scan commands, because prior to 2.8, the way it was written, you could actually impact the performance of your Redis instance, and that was actually not very good. So in Heroku, this is what we espouse and recommend and what you can get on our platform right now. So the last thing I kind of want to leave with you guys today, and that is Redis 3.2 came out a few days ago, and one of the things that really caught my eye as part of this, and I just added this as part of my presentation, was the Redis Geo API. So it got me thinking. Postgres has PostGIS, which does a lot of this geospatial analysis and work inside of it. Is it possible that we might be able to use the Redis one instead of PostGIS? For those that haven't experienced PostGIS in the past, it can actually be quite complex to use. And the challenge there is that you've got a learning curve to scale before you can actually use it with some kind of confidence, and then it's not even available in all of the ORMs that exist out there for applications. To me, it seems like the Redis Geo API has a very good sweet spot if you're looking to do things where you need to know the distance between two things or know how close anything is between each other. So I think that's actually really cool. So again, the question here, is it possible? Is it possible to replace Postgres with Redis Geo? I don't know, maybe. We'll find out. So under the hood, if you haven't had a chance to check this out, they're actually just sorted sets under the hood. And when you issue the geo add command, what happens is that under the Redis will do some geohashing to the values that you give it, the latitude, longitude, and then that is actually the score that's being put in the sorted set. So let's do a little bit of that. This is actually lifted from the Redis.io website, and this is the examples that they give us for this. And I've actually added the last two pieces there just for illustrative purposes. So you've got geohash, Sicily, and Palermo, and that's what you get. That's what gets pulled out of the sorted set. So again, let's go back, create our foreign table. This time I defined it as Redis Geo. I gave it a city and a geohash and said, okay, here's my Redis server, database, table type of zset, and the singleton key of Sicily. All right, let's see what happens. So I select from Redis geohash, and you probably guessed this is probably what I was going to get back. Because the zset is a thing under the hood, I'm just going to get the data structures that live inside of it. So I've got this sorted set of cities and geohashes, but that's really it. So tying these two systems together and using Redis for the geohash, how about no? I don't think there's anything there that we could do. And frankly, you still need to install Postgres, because if you want to take any of your data that lives inside of Postgres, geohash any of the stuff that's in there, and then put that up into Redis, you're still going to have to install Postgres. There's just no way around it. And unfortunately, you can't use any of the geo functions from Redis inside of Postgres. So I had this serious hope that maybe it was possible that I could not have to install Postgres. I mean, don't get me wrong, I love Postgres. I'm a Postgres guy, and I will die saying that every single day. But I was really hoping that I could offload some of that work into another data store, and Redis seemed like a natural choice for this. Unfortunately, it just didn't really work out. So, I did the natural thing, open up an issue with the Redis foreign data wrapper, and maybe someday we'll add geo as a table type now that Redis 3.0 is out, or 3.2 is out. And hopefully, maybe we'll have this dream of being able to offload all the geospatial functions to Redis from Postgres. I really see Redis having this sweet spot for the Geo API, where if you just need to find those distances between two things, I think it's going to be way better than trying to do the whole Postgres thing. Again, any Postgres fans out there, I still love it. I promise. I really do. But again, for more complex things, I really think you're going to need to use Postgres and Postgres. So that's the end of my talk. It was really fast. I wanted to keep this short for the end of the conference, so I want to leave it open for any questions that you guys may have. And I hope you had a great time at Redis conference this year.
So the foreign data wrappers, those are bidirectional?
That is correct. So you can read and write.
So just out of curiosity, this is the first time I'm hearing about it, and thanks for the talk. How does it handle conflicts? What happens when Redis is updating and Postgres is updating at the same time? What happens?
Usually Postgres will just throw errors. That's just what happens. I mean, yeah, it's just as simple as that. That's the best answer I can give you.
Okay. Gotcha.
Hi. So I would just ask, in Heroku, which actually is there a live example how you actually leverage this feature?
Mm-hmm. Do you want to see how we do that, or is that?
like in Heroku, like do you actually use this feature in your?
Oh, like within our own
production
infrastructure, yes. Yeah, so we actually do leverage this right now. So, so the counting, if I go back to the counting example that I had given earlier, I don't have to go through the whole thing, but the point is like we actually use the counting feature. So for commands that get issued via our APIs and whatnot, we'll actually put those counts in Redis, and then from there, we can query that out of Postgres and match that up with any kind of infrastructure information or state that is currently exists inside of Postgres. Because within our architecture, state management happens inside of Postgres, but for some more of the high velocity things that I mentioned earlier, like API commands or whatnot, for users that are trying to orchestrate things themselves, we'll count those in Redis and then bump that up against some more of the more robust information in Postgres. So yes, we do this. We do use this stuff, and it's not like it's just there to help. I mean, whatever.
Is there any other use cases other than that?
The other use cases so the other use cases that I'd mentioned here are things that I have seen. There are things that I do not do inside of Heroku. So like the query caching, that is something that my customers have done, and that's what they use in their applications. So while it's not something that we do in the data team at Heroku, it's something that our customers do.
So to install the foreign table wrapper, do you have to have root SSH access to your Postgres server? How would you handle that, like in a AWS RDS Postgres situation?
I think RDS will allow you to install it. I don't know off the top of my head if you need super user access to do it. All I know is that Heroku can do it.
Also, do you know if there's a comparable thing between Mongo and Redis? Like, I mean, I just thought of this idea. Like, I love the idea that I can access data from both places.
No, there is not, but I can tell you that there is actually a foreign data wrapper for Mongo, so that if you actually wanted to mash stuff up using SQL, you could actually pull from both systems, Redis and Mongo, and then do it inside of Postgres.
Yeah. Thank you.
This is really cool stuff, and I'm just thinking about this for the first time, so my questions may not make practical sense, but I'll throw it out there. So would it make sense then, could you do a join between like a regular Postgres table and the Redis server table or whatever? And then my other question, we're attaching the Redis server to a table. Could you attach it to a column within? And then it would be.
So let me take two parts of that. Can you attach it to a column? No, but in one of the examples that I'd given back here, I think I don't know, wherever it was, you can actually create the view that I was talking about earlier. So you see the view that I created up there. If you wanted to have it as part of a column, what I would do is like create a query that does the joins, so that now you've pulled data from Redis, and then you've pulled data from somewhere else in Postgres, and now you've actually got a new table that like coalesces all that information. So yes, the answer to your first question is that you can do joins across the two systems. Technically speaking, what happens in those cases, and the reason why I keep harping on making sure that you use singleton keys and all of this other stuff, is that Postgres will pull down all of the information that it needs when you're doing those joins from the foreign system, put that in memory, and then do any of the associated hash joins or whatever need to happen inside of Postgres, and then give you the results from there. So because Redis is not a relational system, there's no way to actually push joins down from Postgres into Redis. So you have to be cognizant that when you do joins, all that information is getting pulled into Postgres. So like be careful with the key prefixes that you may have. If you have like millions of keys with a particular key prefix, you might be pulling down a lot of information.
So I had a quick question about hash sets. So if I have a hash set with a lot of parameters in it, generally it's very difficult to add filters if I have a web UI using like showing the Redis database, the columns in the database. I can't just filter on any of the row, any of the columns. I would need to write separate client code for it. So is it possible to just use Postgres and do an order by on any of the columns, or would it just pull the data every time? So if I have a huge set, would it pull the data every time from all that set?
It will pull the data every time. So when you create the foreign table and then you go do that query and then do the order by, it is going to pull it from Redis each time and do that. Now, it may put it into the query cache, and I know that's something that's being worked on, but for the most part, it will pull it down. So be cognizant of that. And one of the things that you could do is actually create, again, do the view. And one of the things that I don't know if it's possible is Postgres has what's called materialized views. So materialized views, what they are like, you could think of them as cached views, really. So you can write your query, pull down the information, and then that information gets stored on disk in Postgres as a view, so that you're just querying that instead.
So can I use Redis as a hot cache kind of deal that the Postgres would automatically back it up and only keep the hotkeys on Redis?
Yeah, I don't see why not.
Okay, thanks.
So that's interesting. So I was thinking this, the FDW is more of like a replication, pushing data into Postgres, but that's not it at all.
It's bidirectional, right?
But the data is only stored in Redis, is that right?
So like, I mean, it's like a little, it's neither here nor there on that. Yes, all the data is stored in Redis. So when you're issuing queries, the thing you have to be cognizant of is, what are you doing with those queries, and where does that data live?
Yeah.
So when you issue a query, let's just say like the selects that I've been doing before, that's always pulling off the foreign table and returning the results to you wherever they may be, with an application code or in the pSQL client like you see here. Now, if you create, and I'm just going out on a limb here, if you create the materialized views, which are those like cached, cached tables in a sense, that stuff will get stored inside of Postgres. I'm not sure if foreign tables can be used inside of materialized views, but if they are, then that data would stay inside of Postgres. But then that would be disjointed from whatever's going on in Redis.
Right. Okay. So the kind of default way is the data is stored on Redis server.
Yep.
And the FDWs are kind of like more like a view themselves then. So like you need to go and select out some data. Ultimately, that's going to cause an operation in Redis, and then that's going to pull back the.
Yeah, it does. I mean, so like one of the things that work on the foreign data wrappers is part of Postgres. I mean, it's still being worked on actively. I know one of the things that it's coming up in Postgres 9.6 is a lot of the joins are getting pushed down to the data stores that can support it, so that you're not pulling all the information all at once, like I had mentioned earlier. And that way you're not pulling like big data sets all the time. But again, Redis is not a relational store, so I don't know that it will ever not pull the whole data set every single time.
Okay, thanks.
Any other questions?
Quick question on, have you done any latency studies? Because we have an app which pulls Redis directly, and Redis is really fast, right? So we take a lot of advantage of that speed. Right now, we are basically channeling data through Postgres. What are have you done any latency studies on that?
I have not personally, and for the use cases that I had mentioned before, like latency is less of an issue for us, because what you'll see, for us and taking those counts against the state information that exists in Postgres, that's more of an analytics use case, so latency is not as important for us. Now on the flip side, when we've had stuff where we're issuing inserts and then putting that into Redis, it's still not, like latency in those cases is not a big deal either, because for the things that I've seen with customers is that they'll put their queries together, the results come back, and then the results end up like just going into Redis at one time.
Fair enough.
Is your presentation available somewhere in the net?
I will post it on my blog, and I think the Redis conference people will post it somewhere as well. So my blog, if you didn't see it, it's neovintage.org. Check it out. And you can find me on Twitter, same handle, neovintage. Neovintage, yeah.
So Postgres is transactional, and if I start a transaction and start inserting into Redis, and then I go back, what's the effect?
There is no concept of transactions when it comes to the foreign data wrapper and Redis. So any commands that you're issuing in that regard are happening right then and there. So rollbacks they don't exist as part of all of this.
So data still gets written to Redis, and what does it do with it? How does it eliminate those?
It just doesn't. Like the commands get issued and then it just happens. Like,
so it just sits there. I can pretty much.
So my point is like when you issue like an insert or something, it's going to happen.
Okay. And if I'm updating stuff, right, and Postgres puts locks on these rows and records. So, but how does that happen on foreign tables if I?
So locks, I mean, it depends on each foreign data wrapper. And for the Redis one, and that's the one I'm going to stick to right now, there is no concept of using, so like Redis has that concept of like transactions as well, but the foreign data wrapper actually does not use that at all. So when you are issuing these commands, like you should just assume that those commands will just get issued as they happen. So there's no like multi-exec functionality that's being used behind the scenes.
Okay, thanks.
All right. Thank you, everyone. I had a great Redis conference. I hope you did too. Thanks for coming out, and enjoy the rest of the afternoon. Thank you.
Head down to the Developer Cafe for the Redis raffle.